All right, I've already talked in our unit circle about pi. We went over the video or the website that showed you what pi was and how we got it. Circumference divided by diameter in every circle gives us pi. We talked about angles. We knew the acute angles, the obtuse angles, the straight angles, the right angles, but there was a new one that we added in. You remember what that one was? The new angle that we talked about started with an R? Reflex. Reflex angles. So just go to the website for a second just to show you again what a reflex angle looks like. Give me a second to log into the internet. All right, angles, reflex angles, just as a review. Reflex angle was the angle that was greater than 180. We could show you them on this little chart here. You had acute, you had your right angle straight up, you had your obtuse. After you pass a straight angle, all of these down here were reflex angles. And you could see where the red arrow shows that it's going on the outside direction. So that was our reflex angles. We talked about that. And then the last thing we did with our unit circles, we talked about radians. And so I'm going to move to the next slide because it's a little picture that just a good little visual of some of the things that you would see that we did on our unit circle. See this blue line right here? That's 1 radius. You see this blue line right here? That's 1 radius. You see this blue line around the circle? That's 1 radius. Okay, 1 radian measure means the angle made by 1 radius. Now that we recall from Friday that it's always going to be a certain number of degrees. Right here, what was it? 57.3-ish degrees, right? 1 radian measures, no matter what the circle is, if you lay 1 radius here, the angle that you make is always going to be about 57.3 degrees. The red line was all the way around. I know you can't really see that very well on your paper. All the way around represented 2 pi. Halfway around represented 1 pi. That was the one thing I told you on Friday. If you remember one thing from Friday, remember that pi is the same as 180. It takes 1 pi to get halfway around the circle. So you give me 1 pi, you can go halfway around. You give me 2 pi's, and you can go all the way around. Okay, that's just a little way to remember pi and 2 pi. This down here is a graph that we're going to be working on. It's called the sine graph. We're going to be talking about that later. That's down like in section 1.4 or 1.5. Moving on. Okay, let's talk about radians. Now this circle has a radius of 10 feet. If it's got a radius of 10, a 3-foot arc would have a measure of, and I'm going to put that up here, it would have a measure of 3/10 or 0.3 radians. Okay, if the radius is 3 feet long or 10 feet long, and you do a 3-foot arc, you're not going to 1 whole radian. You would have to do a 10-foot arc to get 1 radian. If you're only going 3 feet, you're only going 3 out of the 10, so you're going 0.3 radians. Now before I move on, I want to talk a little bit about this symbol right here. You see it in the picture, and it's right here. It's called theta. Theta. Greek letter, Greek symbol, just like pi. But it's what we use to kind of represent our radian angle. So we usually use this to represent radian measure. That's just a common rule of thumb, is that you use theta to represent radian angle. If I put an x in there, then I might be looking for degrees. But if I put a theta in there, then I'm probably looking for radians. So this theta represents radian measure. So if I know that my whole radius is 10, and I only go up 3 feet, then that's going to be 3/10 of a radian. It's going to be 0.3 radians. What if I went up 5 feet on the circle? That's 5/10 or 1/2 of a radian. That's not a whole radian. That's just half of a radius, half of our radius. So our radius was 10 and we only went up half of the radius, we went up 5. So that'd be 0.5 radians, or 1/2 of a radian. 31.4 feet. If I put 31.4 over 10, when you divide by 10, what are you going to do to this decimal point? Move it over which way? You're dividing, you're going to make it smaller. It's going to be 3.14 radian, or 3.14 feet, or 3.14. What do we know about that? That's pi. So if I was to go 31.4 feet, okay, look at that on here. From here to about here would be 10 feet. From here to here would be 20 feet. From here to here would be 30 feet, and I'd have 1.4 feet left over, which is what makes up pi. So you've got 3.14 radiuses that would give me pi. So halfway around the circle is pi radians. Halfway around would give me 3.14 radiuses to get there. So that's how the radian works. If you remember anything, remember that pi equals 180. There are 3.14 radiuses that would get me to 180 degrees. Good move? Okay, so 180 degrees equals pi. That's something that you need to remember. 180 is pi. So if we know that 180 is pi, then how much is 30 degrees? 30 degrees is going to be 1/6 of a pi. If you're gonna break it up, you could put 30 or 6 30-degree angles that would fit in 180 degrees. 6 of these 30-degree angles. In other words, I could take 30 degrees and multiply it by pi over 180. Because what do I know about pi and 180? That's what pi equals, right? 180 degrees. If I want to find out how much 30 degrees is, I'm going to put the pi over 180, and I would cross cancel here, and that's a 1 and a 3, or 1 and a 6, I mean, and that's going to give me pi over 6. So if I wanted to go from degrees to radians, I could simply multiply by pi over 180. That would give me the fraction pi over 6, because there's 6 of those that would go into 180. You want the 180 on the bottom, because you want to see how many of those 30s could go into that 180. What about 45 degrees?
1/4.
Yeah, it's going to be 1/4. There's 4 of those, 45-degree angles that would be in 180. So this would just be pi over 4 radians. Pi over 4 radians. Could I use the same method here to find pi over 4? I could. I could put 45 times pi over 180, and that would give me, if I reduce that to a 1 and a 4, that would give me pi over 4 radians. What about 60 degrees?
1/3.
It's going to be 1/3. There's 3 60-degree angles that would fit in 180. So this would represent 1/3 of a pi, there's a second third of a pi, and there's 3/3 pi. So that would be 1 whole pi. So 60 degrees would be pi over 3. 90 degrees would be just half of a pi. Remember, it takes 1 full pi to get to the halfway point. If you're going 90 degrees and you're just doing half of that would give you the half of a pi. 270. Now I'm missing something on that picture. I'm missing an arrow that shows which direction I'm going. Kind of missing that here too, because I could put this like that. So that's going to tell me that's half a pi. But I'm measuring like this. So I'm measuring that angle. That's called a reflex angle. It's bigger than 180. So you're measuring the outside. That's the 3 pi over 2. What that means is 3 pi over 2 is the same thing as 1.5 pi. Remember, 1 pi is 180. So if I go from here to here, that's 1 pi. And then I got another half. So I've got 1.5 pi's that would get me down to here. Because what is it if I go all the way around? It's 2 pi. So from here to here is only 1.5 of those. I got to go all the way around to get to the 2 pi's, which is my last one down here. My last one, 360, is the same as 2 pi. And what I'm going to do here is put my arrow to show that I went all the way one rotation. That's what 2 pi is. 2 pi is starting and ending right where you started. You go all the way around the circle once. You get around once, you got to do 2 pi. 1 pi is halfway. This would be 3.14 radiuses to get to here. That's pi radiuses. And then you need 3.14 radiuses again to get to the end. So you need 2 of the 3.14s, you need 6.28 of those radiuses to get you all the way around the circle. Exactly 6.28. I mean, it goes on forever. So that would be just a look at the common angles. These are the angles that you're going to see the most. 30, 60, 90, 90, 270, or 30, 45, 90, and 60, and 270, and 360. Those are the common angles that you'll see. All right, good to move? Not yet? Move on. All right, moving to the quadrants. Not a whole lot to write on this slide here, but I want to show you a couple of things. We want to look at the quadrants. Here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. We know how to get there with our positives and negatives. So quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 was negative, negative. Quadrant 4 was positive, negative. Those were the coordinates on our unit circle when we put those in. But what we want to look at is the radian angles. In this first quadrant, you're going to get all angles that are between 0 and pi over 2, which is half of a pi. So if your angle is somewhere between 0 radians and half of a pi radians, or pi over 2 radians, it will be in quadrant 1. Like pi over 3, like pi over 6, even like pi over 5. This is like 1/3 of a pi, that's 1/6 of a pi, that's 1/5 of a pi. All of those are less than 1/2 of a pi. So they're all going to be in quadrant 1. So anytime you see any of these angles right there, you'll know that it's in quadrant 1. You should be able to just look at an angle and say, okay, that's 3/4 of a pi, so that's got to be in quadrant 2, and that's 1 2/3 of a pi, it's got to be in quadrant 4. So you should be able to know where the angles would go. This one is going to be from half of a pi up to a full pi. Anywhere from half of a pi up to a full pi. So like we had a couple, I think we had 2 pi over 3. That was 2/3 of a pi. That's bigger than a half, and it's less than 1/2. 2/3. Like 3/4 of a pi. That was also bigger than 1/2 and less than 1/2. And there's lots of those, like 7/8 of a pi. You could put 7/8 pi in this category. 7 pi over 8 would also be bigger than a half and less than a whole. 7/8 is less than 1/2. Quadrant 3, you're going to have anyone between 1/2 pi and 1.5 pi. So I think we did like 7 pi over 6, 5 pi over 4 were some of them that we had. So that's 1 and 1/6. That's going to be less than 1.5 and more than 1/2. So those are going to be angles that are in quadrant 3. Quadrant 4, you're going to have angles that are between 1.5 and 2. I think some of the ones we did was like 11 pi over 6. I think we did 7 pi over 4. Those are all angles that are bigger than 1.5, but they're less than 2. They're less than 2 pi's. So they're bigger than 1.5 pi's, but less than 2 pi's. So those are just quadrants. You're going to have a couple of questions on the homework that are going to ask you what quadrant things might be. So you should know if it's between these two, it's in quadrant 2. If it's between 0 and 1/2, it's in quadrant 1. So that would be just that one. All right, let's talk about coterminal angles. One of the main gists of trig is to know what a coterminal angle is. Coterminal angles are angles with the same initial and terminal side. Initial is where the angle starts, and terminal side is where the angle ends. you're going to start and end at the same place. Like this angle right down here starts here and ends right there. Right? Starts flat and ends right there. But what would happen if I started here and went like this? Did I still start in the same place? Did I end in the same place? So it's the exact same looking angle, but it's going to have a different measure because one went up and one went down. Right? Question? Okay, basically what it means when they're going to start and end at the same spot. So this angle right here starts here. It could end if we go up, and it could end if we go backward. It's going to have the same. It just depends on the different rotation that you're going to do. So they're going to have different rotations. So this angle right here, we're going to call it a pi over 6 angle, which would be like 30 degrees, right? We're going to call this angle, backwards angle, 11 pi over 6. Negative. So it's a negative 11 pi over 6 angle. Let's see how we get there. I'm going to start with my pi over 6 angle. Okay, so I'm going to start by going up to this line right here. So my first step is just to go up. Then from this angle, so what I did is I went from here to here, right? Follow me so far? Then I'm going to subtract 2 pi. Now what does 2 pi represent on my circle? 2 pi is what? 1 rotation. So I went from here to here, and then I'm going to go 1 rotation back this way. And what did I end up at the exact same place, right? I started here and I ended here. I went 1 rotation backwards. So I subtracted a circle. So I went up to here, and then I subtracted a circle from it. Now, how can I subtract those two with one being a fraction and one not being a fraction? Could we make this one a fraction? Could I get a common denominator? Yeah, multiply by 6. And so what is my what's my new fraction going to be over here? It's going to be 12 pi over 6. Do you see how 12 pi over 6 is the same as 2 pi? Because if you divided 12 by 6, you'd still get 2, right? Now I can subtract. What do I get when I subtract? 1 pi minus 12 pi. Negative 11 pi over 6. Does that look familiar? That was the angle that we knew it was going to be. It's because when you started here and we went to here, we went a negative 11 pi over 6 angle. That was what you put on your unit circle, or you could add on your unit circle if you did the negative radians. So what I did was I subtracted 1 rotation. This minusing 2 pi right here means you're subtracting 1 rotation. And then I got the exact same angle that looks exactly the same, but one is going to be pi over 6. The other one is a negative 11 pi over 6. Okay, what if I was to do this little problem on this side? So let me draw another little picture. Let's draw our pi over 6 angle again. Okay, there's pi over 6. What if I did another rotation forward? What if I went up to here and then went all the way around again and went back to there again? So I would add a rotation. I'd add 1 circle. Could I change 2 pi to a common denominator? Yeah, it's right here, 12 pi over 6. So let's change this to 12. Change it to 12 pi over 6. So what's 1 pi over 6 plus 12 pi over 6? 13 pi over 6. These two angles are called coterminal angles because they look identical. They both start and end in that same spot, but one goes up a little bit and one goes around one. You can go around the circle as many times as you want to go around the circle. You could keep adding rotation after rotation after rotation. If I added 12 plus 13, I'd get 25 pi over 6. That's another angle that looks exactly the same, but it's around one more time. In Trig, you can go around the unit circle as many times as you want. Yeah. Because I wanted to show you that you don't have to just get negative coterminal angles. You could also get positive coterminal angles just by adding another rotation to something. So you can get a negative one or you can get a positive one just by adding a rotation. Okay, let's look at the positive and negative. You can have a positive, you can have a negative coterminal angle. Find a positive and a negative coterminal angle for each one of these. Okay, so let's find a positive one. Let's add one rotation. 2 pi is one time around the circle. So how would I add 3/4 or 3 pi over 4 and 2 pi together? How would I put those two together? You got to get a common denominator. Yep, you got to put a 1 under this and change it to what new fraction? 8 pi over 4. That's going to be the same as 2 pi. 8 pi over 4 and 2 pi are the exact same fraction because 8 divided by 4 is 2. Now I can add my 3/4 plus my 8/4. What's 3 plus 8? 11 pi over 4. That would be my coterminal angle to this one. These two are coterminal. That means they look identical. Okay, let me show you what they would look like. Okay, you would have an angle, 3 pi over 4 would go right to there. Okay, watch this closely. 3 pi over 4 would be this angle. Starting here and ending here. That'd be 3 pi over 4. 11 pi over 4 would be that angle right there. You started in the same place and you ended in the same place. You just went around one extra time because you added one extra rotation there. That's a positive one. How do I get a negative coterminal angle? You just subtract the 2 pi minus, and I'm going to change that to 8 pi over 4 right away. I already know that I need 8 pi over 4. What's 3 pi over 4 minus 8 pi over 4? That's your negative coterminal angle, negative 5 pi over 4. So these are also coterminal angles. Okay, let's look at the negative 2 pi over 3. Okay, so negative 2 pi over 3. Let's get a positive coterminal angle first. So what should I do to get a positive coterminal angle? I need to add one full circle, one full rotation. So I got to add 2 pi. I need to change 2 pi to a fraction that would give me a common denominator. 6 pi over 3. Good, because 6 divided by 3 is 2. So I can get rid of that now. What's negative 2 pi over 3 plus 6 pi over 3? That's going to be a positive 4 pi over 3. That's your positive coterminal angle. These two angles, coterminal angles. They're the same position angles. They look exactly the same. Well, they'll start and they'll end in the exact same position, but one will have a different rotation. How about a negative coterminal angle? Negative 2 pi over 3 minus a circle. Actually, I'm just going to put negative 6 pi over 3 right away because we already know that that's 2 pi. So what's negative 2 pi over 3 minus 6 pi over 3? Negative 8 pi over 3. Those are also coterminal. Those are the exact same angle. They look identical, but one has one more extra rotation to it. So they're angles that start and end in the same place, but they have an extra rotation. So that would be coterminal angles. And we have one last slide that I want to do today, and then we'll move on for tomorrow. So this will be part 1 video on the notes. We good here? Okay, we got complementary and supplementary. We recognize those words, hopefully. Complementary are angles that add up to 90 degrees. Supplementary are angles that add up to 180. But now we also measure things in radians. We learned that 90 degrees is the same as pi over 2 radians. It's half of a pi. So 90 degrees is 1/2 of the way to 180. So it's 1/2 of a pi. And we learned that 180 is equal to pi radians. 3.14 radiuses would get us to 180 degrees. So we want to find the complement and the supplement for each of those angles. I'm going to move it up just a touch. Okay, find the complement and supplement of each angle. So let's say that, review for a second. What if I wanted to find the complement of 50 degrees? You take 90 and you subtract 50 and you get 40 degrees. So 40 degrees and 50 degrees would be your complementary angle. So I need to start with my 90 degrees, which in this case is pi over 2, and I need to subtract the 2 pi over 5. Because I need to find out what would add to the 2 pi over 5 to make it equal to pi over 2. The pi over 2 is the big one. That's the one we're going to start with. That's the biggest angle there. We want to get them to equal the pi over 2. Could I subtract those two fractions? If I get a common denominator, I can. What would be my common denominator there? 10. So let's make them both into tenths. What would this first one be? 5 pi over 10. When the half is the same as 5 tenths. And this one, if I multiply by 2, I'm going to get 4 pi over 10. So what's my complement? 1 pi over 10 or just pi over 10? This one, this angle plus this angle together would add up to a half a pi. They would add up to 90 degrees. So pi over 10 radians and 2 pi over 5 radians would give me 90 degrees, or pi over 2 radians. Those are complements. So what about a supplementary angle? So right here I'm going to write complement. What about a supplementary angle? So I'm going to start with what? Pi this time, because I want them to add up to pi. So pi minus 2 pi over 5. So pi minus 2 pi over 5. What could I change pi into so that it would have a common denominator? 5 over 5. You just want to do 5 fifths. So 5 fifths. 5 fifths minus 2 fifths. That gives you how many fifths? 3 fifths. So that would be your complement, your supplement. 3 pi over 5. So now in your head, 3 fifths plus 2 fifths gives you the 5 fifths, which is 1 pi. So this would be your supplement right there. So supplement. All right, what about 4 pi over 5? Last one here. We want to take pi over 2 and subtract 4 pi over 5. Let's get a common denominator again. What's it going to be? Common denominator will be 10 again. Okay, this is going to be 5 pi over 10. When I multiply these by 2, 8 pi over 10. So 5 pi over 10 minus 8 pi over 10. What's 5 minus 8? Negative 3 pi over 10. Can you have a negative complementary angle? No. So you would cross it out and you would put no complement. What does that mean, no complement? What do we know about the original angle then? It was already bigger than 90. There's nothing you could add to it to make it equal 90. Or there's nothing you could add to it to make it equal to pi over 2. It's already too big. So there's no complement when it's too big. So you would just put no complement. It's too big. Pi minus 4 pi over 5, though, it does have a supplement. If I put 5 fifths again in front, 5 fifths minus 4 fifths, it's just 1 fifth, so it's just pi over 5. That would be your supplement. There is a supplementary angle there. There is not a complement because it's already past pi over 2. This angle right here would be in quadrant 2 already. So it wouldn't have a complement because it would be past the pi over 2 angle. All right, we will finish part 2 of the note tomorrow. This was part 1.